Okay, so what we're going to talk about in this tutorial is how to graph logarithmic functions. We talked in another tutorial about graphing exponential functions. Now we're going to do the inverse of that, which is logarithmic functions. So let's start with the characteristics of any logarithmic graph. We're going to focus on two key points. And again, these are the reverse of what we did with exponential graphs. So my key points are going to be 1, comma 0, and then whatever the base is, comma 1. And the asymptote will be a vertical asymptote at x equals 0. So let's take a look at this example, log base 4 of x. So the first thing I want to do is I'm going to go ahead and graph the asymptote. So I know that my asymptote is going to be x equals 0, so essentially right on top of the y-axis. I would recommend putting the asymptote in before you do anything else. Now what I want to do is I want to highlight those two key points. So I know I'm going to have 1, 0, and since my base is 4 here, it's going to be 4, comma 1. So I'm going to plot those 2 points, and I'm going to draw my curve. I'm going to hug the asymptote, go up through the 2 key points, and it goes on forever. And that's it. So that's how you graph f of x equals log base 4 of x. Now let's talk about how to do the different transformations. So we're going to talk about 4 transformations: shifts up, down, left, right, and then reflections over the x and over the y-axis. So I've given you 4 examples over here on the left, and we're going to go through each one. First thing I want to do is I want to just copy over the graph that I had done on the previous page. We're going to start with log base 4 of x. So I had 1, 0, 4, 1, and curve up through like this. Now, if you've already taken a look at the tutorial on exponential graphs, the way we're going to handle these is identical to the way we handled exponential. So keep in mind that the kind of rules that we talked about with exponential graphs are not going to be any different for logarithmic graphs. So let's start with the blue one. I have log base 4 of x plus 3. So what I want to focus on is this plus 3. When we are adding or subtracting a number not in parentheses, again, notice the difference between the red and the blue. In the blue one, the plus 3 is not in parentheses. That's going to move me either up or down. In this case, since it's plus 3, that's going to move me up 3. So what I'm going to do is I'm going to take my 2 key points and I'm going to move them up 3. And my shape will not change. It's the exact same shape. It's like I just picked it up and moved it up 3. That's it. You're done. That is the graph of f of x equals log base 4 of x plus 3. Now let's talk about the red one. The difference between the blue and the red is the transformation, in other words, the minus 3 here, is inside parentheses. When I'm inside parentheses, that's going to move me either left or right. And it's always going to be the opposite of what the sign is. So since this is x minus 3, that's going to move me to the right 3. If it had been plus 3, I would go to the left. So you always have to think opposite direction of what that sign is. So I'm going to take my points and move them to the right 3. And I'm also going to draw in a new asymptote because since I moved to the right, that will move my asymptote as well. So I want to draw in a new asymptote. If you're wondering why I didn't draw a new asymptote for the blue one, it's because if I move up and down, that will not adjust my asymptote. It'll stay where it was initially. Only a left to right shift will move it. So now I have this curve right here. And I'm done. So that's it for f of x equals log base 4 of x minus 3. Now let's go into the 2 kinds of reflections, over the x-axis and over the y-axis. So the first one, the green one, I have a negative out in front of the log. When I have a negative outside of the function, that's going to reflect me over the x-axis. So what I'm basically doing is I'm mirroring my graph over the x-axis. So I'm going to take my 2 key points and I'm going to reflect them over the x-axis. Now notice how I don't have to move 1, 0. I don't have to move 1, 0 because it's on the x-axis, so it's not possible to move it anywhere. It's going to stay put. But I reflected the positive 1 down, so now it's negative 1, and my curve will be like this. So you'll notice that it's just a mirrored image over the x-axis. And that's it. Now the last one, the one at the bottom, the black one, that is going to be a reflection over the y-axis. When I'm inside the parentheses, that will reflect me over the y-axis. So I'm going to mirror my 2 key points over the y-axis. So I'll have an image that looks like this. Sorry about that, that didn't turn out too well. But there you go. So it's been reflected over the y-axis. And that's it. So what I want you to think about is the blue and the green are connected from the standpoint of they were transformations outside the function. So that affected me in an up and down or a vertical direction. Whereas the red and the black were transformations on the inside of the function. So that affected me in a horizontal direction. In other words, left and right. Now, if you're still struggling with these transformations, what I would encourage you to do is get a graphing calculator and just practice some transformations. So what I've done is I have my graphing calculator up and I've graphed log base 2 of x twice, because what I'm going to do is I'm going to change the red one. I'm going to leave the black one alone and I'm going to change the red one. And I'm just going to start adding and subtracting numbers. So if I'm on the outside of parentheses and I start adding numbers, add 1, add 2, add 3, notice how that's just moving me up. That's all it's doing, it's moving it up. If I subtract numbers, that's just moving me down. The shape is not changing, all it's doing is moving me up and down. Now if I go inside parentheses, notice how I'm taking my graph and I'm just shifting it. Every time I change that number, it's moving me further and further to the left. Whereas if I subtract a number, it's moving me further and further to the right. But in terms of the shape of the graph, nothing's changing. I'm just sliding it either left or right. Now let's talk about negatives. If I have a negative, if I multiply by -1, for example, notice how that just reflected me. All it did is it flopped that original graph over the x-axis. Whereas if I put a negative on the inside of parentheses, that mirrors me over the y-axis. So again, if you're still struggling, I would say just go to a graphing calculator and just play around with adding, subtracting numbers, see what happens to the graph when you do that. Okay, that's good practice and a good way to kind of help it sink in. So again, hopefully you understand what these 4 different transformations do, and no matter what the base is, we're going to handle these graphs the exact same. Remember the 2 key points, 1, 0, and the base, comma 1, and remember that you're always going to have a vertical asymptote. I hope that helped you. Good luck.